So this is quite a random talk, because kind of what I do is I recycle the mess that our installed base manages to generate, and then we go and try and work, or we generate some of it and third parties generate other bits, and try and sort of learn some lessons and think about, well, how could we collectively avoid putting our foot in it. So some of it is that, and then some is some tools and techniques that I find many people haven't come across. So I'll try to sort of publicise those. And it is kind of, what did you want to talk about? Because if there's stuff I don't cover, say, oh, you know, can we talk about the stuff that takes your particular interest? Then, you know, put your hand up, say, can you talk more about that? And I'll have one of two answers. I'll either go off with a load of enthusiasm and talk about it, or I'll go, I don't know anything about that. So computing is this big, and I know a little bit. I know a bit about the bit I know, but there's a lot I don't know, and if I don't know, I won't tell you, because I don't know anything about it. And there may be things that I'll try and do plausible denial. And I'll be a sort of, I've got a golden retriever, so I'll try the golden retriever look. Just like that, okay? So, please read. Yes. Good. So let's start with some futurology. I have no idea what I'm doing tomorrow, so this is my 3-year sort of prediction for the future, and take them all seriously, please. Where do I stand so that the camera can see me? So I've been involved in a couple of issues, sort of escalations, which are always unpleasant. I'd get to go to the Grand Canyon for one, where it's been 10 gig, but we can see 40 gig Ethernet kind of coming in the next while. And there'd been a major driver of performance issues which have been extended in terms of time and pain and finger pointing opportunities. And I think this is going to be a major driver over the next couple of years. It's not Solaris specific, in fact. Some of the ones I've been involved in, there was also other vendors and other operating systems involved. But I think this is, we're going to see a raft of between switch vendors and system vendors over the next year, much in the way for storage vendors. There are no 3-letter acronyms at all, where we would see IOstat having high latency, and we'd say, looks like your storage is going slow. So, no, it's not. Well, it really does look like it's... Oh, it's your host bus adapters. It's multipathing. You should be using ours. And eventually they kind of upgrade firmware, or front-end ports would be moved around, or there'd be disks that would be made less busy, and magically the performance issues would go away. Though I did manage to see one customer where I was just seeing high service times, and apparently they plugged a PC into their SAN, and it was generating complete garbage, and they took most of their business down. Had a faulty HBA, so I thought very... So I also think at some point it will be worked out in companies that having sysadmins, network and storage folks in different reporting structures, possibly even working for different companies, will be suboptimal. I'm staggered that this is probably the biggest contributor to extending resolution time of critical issues in my world, is that people don't work for the same organisation. And it's governance is broken. It's a great word, governance. To you, don't know what it means.
I also think you expect that to be fixed.
No. Well, I think somebody will read. I wish it would be. I refer the right honourable gentleman for Cambridge to this one here. Right. I think there'll be legislation that will be introduced to limit the complexity of networks. So you've got things like aggregation and LACP and IPMP and a whole pile of stuff that I absolutely hold my hands up and I don't understand, but seems to be able to make producing a robust, performant, diagnosable network, fast network, a thing that requires divine insight. So I think there will be legislation, certainly from the European Commission, on this network complexity in data centres. I'm certain of it. Something that it's so obvious that it's going to happen, it's not even futurology, is that for requests for proposals for large infrastructure, actually they're going to start thinking and writing down requirements for diagnosability. So one of the constants in computing, at least for me, is that things break. I write code, it's in Solaris, every so often you do something wrong. And you think about 10 million lines, things are going to go wrong. You think about how big solutions are, things are going to go wrong. It's actually quite important that we can diagnose it. So again, pixies, fairies, flying pigs will oversee this. But I think that will make a big difference. One thing I actually do think will happen, and we're starting to see this, maybe less in the UK but some of our external customers elsewhere, is that there are customers who are going, we've got so many machines using so much power, so much rack space, and we are really struggling to manage these things. And they will be turning to larger systems and consolidation. And that's becoming more of a trend that I'm certainly starting to see. And it just makes, and that drives network complexity, which I think is going to be the one that's going to cause people to freak out. I also, I've been predicting this for a while, incorrectly, but hey, I don't even know what I'm doing tomorrow, that there will be some computer-induced events with significant loss of life, or much worse, around here, money, which will lead to some IT roles being regulated. And you think, oh, in the UK, then we look at the British Computer Society. Well, they're up to the task. And without a question, Led Zeppelin will tour again. Robert Plant lives in mid-Wales. I'm sure of this. So anyway, that's my futurology. I put those up there for discussion, and so pick holes in them later. So I'd like you to introduce to the iceberg of performance. This could be a have I got news for you game. So I have a chair. Have I got news for you? I will do the iceberg of performance. So I think there's, in my performance world, there's kind of two parts. There's a little bit on the top that you can see, and this is optimization. This is what I'm really careful about. Optimization is, we've got this solution, how do we make it go faster? Okay, and that's the tuning to me. And I have a big distinction. And this is kind of the rest of making a system performant. So above the waterline, you only worry about the stuff above the waterline when everything else is working as it should be. And I don't know what the ratio is. Do you even know what the ratio is?
10 to
91?
10% to 90%.
10%, okay. That sounds about right. Is the this max here is what we as vendors, and Oracle not particularly, we will do things to you. We will introduce bugs. We will give you duff advice in products. It goes everyone does this, not intentionally, but it does happen. As vendors, you will. As customers, you will ignore advice that we give you. You will not read documentation that we've got that we try and obscurely hide. Some of it will just be very, very complex. There will be interoperability issues that nobody could foresee. And this is kind of the interesting bit to me, is getting, this is minus fast in a compile line. This is tuning, little bits, let's get 2%, 1%. This is I'm trying to do, support 10,000 users, I can only support 5,000. They all come from down here. And that to me is the interesting bit. So how many people are interested in the Meldrew depths? And that's why I don't believe it. Rather than optimization. How do I make my fluid dynamics program go 0.5% faster? Who lives up here? And who lives down here? Up here? Down here? Who lives somewhere else? Where do you live, Peter?
Why the hell doesn't it work?
Why? Because it's complex and hard.
I know that.
These are, you know,
Yeah, because of that, because the developer says, oh yeah, sure, you can reformat the hard drives on our database service because we don't need them 2 weeks before they were taken out of service.
Oh, then and that comes to the G word, governance. That's a different talk. Yeah, it's really funny because I found this word called governance and I didn't understand what it. I used it in a meeting once, and there were a load of managers in there. And they went, "Oh yes, governance is broken." I was really lucky they didn't say, "Well, what do you mean by that?" Because I hadn't had a clue. So I looked it up on Wikipedia, and it's kind of who makes the decisions. And in that case, there was a configuration error, and the group who should have been making sure that configuration was right weren't the group who knew what to do. That was a governance problem. So yeah, just always a governance issue. Getting the mindset of the...
We used to have to say the buck stops here.
Where does it stop?
Exactly.
Yes. So anyway, there's not depressing here, but that's where I'm interested in, and so computers. This may come as a surprise to many of you, but computers are getting faster and bigger. Okay, that's right. So when I sort of started, a Spark Station 1 had one CPU and not a lot of memory. And so last year, that was 4 terabytes, 512 CPUs. And I don't want to take Larry's, he does the product announcements, Oracle Open World, maybe. We're looking at the sort of scale of 100 terabytes of physical memory, 10,000 sort of virtual CPUs. And that's just in a box. And when we start networking it, the complexity is just becoming mind-blowing. And one of the things that I'm doing, and if you're interested in this at all, is trying to think, well, okay, how do we get scale post-mortem diagnosis on machines that are going forward? Because even just taking a crash dump from a system, imagine a crash dump from that. Did that have deep thought, a panic?
Need a few years to read it.
Well, you're going through that with NDB. Life at the University. So anyway, this is Clive's guess at how many lines of code are in a solution. This is Clive's guess. I mean, blow it away. Say I'm wrong. Under overestimating. And this is this is a level of complexity and interaction. I didn't realise that there are 25 different flavours of InfiniBand. So in the engineered systems, one of the reasons they kind of work better is because we pick one. Oh yeah, but the other one has advantages. We pick one. And maybe one of the differences between Oracle and Sun is we can do all this stuff. 25, and Oracle is we pick one. So this is kind of frightening, but it's good because it gives me quite interesting stuff to do, and because I like customers having problems, and to go to interesting places and meet interesting people. But ultimately, it's getting this stuff to work together. It freaks me out. And my brain cannot cope. So this was quite a small machine, and the tools we have, I mean, imagine starting to look through it's being a crash dump of NDB. Imagine starting to look through this when you've got 1,300 times as many CPUs and 1 million processes. And I really think we have to be cleverer. Years ago, the student, when I was in, I think I was working for Sun, but I supervised a student in Aberystwyth who did a master's, and got him to build a virtual world, mapping MDB to Quake, and walk around this virtual world. So I'd like to see that happen. But okay, so there's going to be some techie stuff, and then there's indulge me, because I kind of think this is important. But you know, why is it so difficult to solve some types of performance problem? And efficient use of tools and the facilities the operating system supports kind of has to support the right sort of thinking. And I think there's people that sort of struggle with some words. One is guess. And it's very difficult for some people to understand the difference. Maybe it's a public thing, maybe they understand it internally. The difference between a guess and a fact.